Okay, in this video, I'm going to take a little break from all the busy work of having to go with the GCF calculator and that T chart and all that. But I do want to make, because you guys have done a good job with not complaining, doing what you're supposed to, and I do appreciate that. So we're going to switch gears a little bit, and we're going to go with something easy. You have a calculator because you only need to use it for one thing. A lot of the problems you won't even use it. You're not actually going to find the answers to these equations. What you're going to simply do is at least set the equation up to be solved. So you're going to follow this process here on this sheet of paper. So here's step number one. Determine how many answers x would have in the equation. Well, it's to the second power, so that means it would have two answers. So put that there. That's easy enough on step one. Step two, determine the powers that x has in the entire equation. Well, look at your x's to the second and to the first. So we have x to the second and x to the first. Okay, do you need factoring boxes? Well, anytime I have that x second and x to the first, we need the factoring boxes. So if you do, is your equation equal to 0? It is equal to 0, okay? So you're going to write set. Now, what are the boxes I need? Okay, well, how many terms are there? There's 2, okay? 2 terms. So 2 terms is the greatest common factor box. And then my difference of perfect squares box. Stop the problem there. Okay, stop it there. We'll actually do them next week, but just you can stop your process there. Okay, now the next one, again, just run through this right here. Determine how many answers x has. So again, having the x to the second means there are 2 answers. That's the highest power exponent. My variable is 2. So that's how many answers I would need to find. I'm not going to find them, okay, and that's fine, but at least set it up. So I look here, we have x to the second, and we have x to the first as well, okay, because the x second, and that x is just to the first. Okay, so do you need the factoring boxes? Yes, when I have x to the second and x to the first power, we need to factor, okay? So if we do, which we need them, is your equation equal to 0? Yeah, so write the word set, S-E-T. And what are the boxes I need? Well, that depends how many terms I have. I have 1, 2, 3. So that would be the GCF box. Because whenever you have these two, whenever on step 2, if you've determined you have an x to the second and x to the first, well, you're going to need the boxes. So you have to see this, make sure the 0's there, and then count how many terms, 1, 2, 3. So that's the greatest common factor box, and then my T box. Okay, let's move right along. 2x plus 3 equals 4x plus 10. Determine how many answers x has. Well, I don't see any power at all in the whole equation, okay? So there's only one answer. Now in step 2, determine the powers x has in the entire equation. Now I don't see any powers at all in this equation. So what I'm going to put up here is regular x only, okay? And when I have regular x only, okay, that's the only kind of x I have throughout the whole equation, because those aren't any powers, those would be like terms, you need to just write no boxes needed. And I wouldn't need any boxes. I just put a plus on that 4, minus it from both sides, and I dot, and then minus the 3 and divide. Okay. Okay, now the next one. This one you're going to need to make some calculations on your calculator. Now, it's kind of confusing, but at least it's something different. Determine how many answers x has. Well, when I look through this, the highest power x ever has is a second power, okay? We have 3x second, 10x a first, and that would be a 1, negative 1x second, and then 2x a first. So we can see that there are two answers, okay, because the second's the highest. So I look through that, and I have x to the second powers and nx to the first powers. So with these two, you're going to need to make the boxes. If you do. Now, is this equation equal to 0? No, it's not set. So you need to set it yourself. Now, here's how to do that. Because if you need the boxes, okay, which you always do when you have these two things, x second and x first, the equation has to be set equal to 0. Because right now, this is a mess. I don't know how. I have no idea how many boxes I'm going to need, or what the boxes are, until the equation is set equal to 0. So here's how I'm going to accomplish that. I have to do the set myself. The highest power is a 2, so set up your little spaces, blank x to the second plus blank x plus blank equals 0. And here's what we do. Now remember, what I want to do is get these over here, okay? But it's kind of confusing when you have to do the plus, plus, minus, minus. So here's what I would suggest. Just make these numbers into their opposite, okay? Because you want to move them over here, but you know it becomes very jumbled and very confusing. So this is -1. If I want it over here, if I want this out of here, I'm just going to make it +1, and that allows me to add it over here. Now, if that's +2, I'm going to make that a -2, and then again, that allows me now to add it to things that are over here. So x to the second, I have 3 and +1. Well, 3 plus 1 is 4. Now, for regular x, we have a -10 and a -2. Remember, regular x means x to first, so I add now. See, switching the signs over here allows me to add them to things over here, okay? Because it's like the plus, plus, minus, minus, but that's confusing when you're doing this. So it's better if you just change the signs on the terms that are over on this side. Okay, so -10 plus -2 is -12. Okay, and then for numbers without x's, all I really have is a -7. Okay. Well, now I can see how many terms I have. There are 3. Okay. 1, 2, 3. So GCF box, and then the T box. Okay, my next problem, determine how many answers x has. So there are 2. So because you know you have x second. Now you've also got x to the first too. So you have x to the second and you got x to the first. So that's step 2, just determine the powers x has. So we're going to need the factoring boxes with these 2 different powers. Always do. Now, we are going to need the factoring boxes. By the way, if I'm going to put x second and x1, I'm going to put the word need boxes. Okay. But before I can make my boxes, the equation has to be equal to 0. And right now we're not. So I'm going to put equals 0 myself. And when I do that, I put the highest power, blank x second, plus blank x, plus blank. Now, anything on this side, I make into its opposite, so it can really be added over here. So that +14 is now a negative. Okay? And this is pretty easy to see. X the second, we just have the 7. X, we have the -14. And then I really don't have any numbers without x. So I'm going to delete that box. Now, how many terms do I have? I have 1, 2. So that would be greatest common factor, GCF. And then seeing if I have a difference of perfect squares, because that's what we do with, you remember that sheet you had? I don't have it on your desk today because you really don't need it, okay? Just 3 terms is this and the T, 2 terms is this and the dots, okay? But before you go to your boxes, you have to have your 0, okay? Then we'll solve these equations at a later date. Okay, this problem right here. Determine how many answers x has. I think the second power is the highest power I see. I look through this equation then, because I know I've got x to the second, 1. I know I've got x to the first, and another x to the first. So I have x to the second as my highest, but then there's an x to the first with it, okay? So again, with this and this, do you need factoring boxes? And the answer is yes. So I'm going to put need factoring boxes. But before I can make them, is your equation equal to 0? Now, I don't see 0, so I set it equal to 0 myself. And then x second's the highest, so blank x second plus blank x plus blank. Okay, so remember, these things need to come over here. Now, rather than minus 8 and then find the number to minus 8 to, and then plus 3x the first and plus 3x the first is some number, that clutters up I can't see what I'm doing. So instead, what I'm going to do is simply switch my positive 8 to a negative 8, and then my negative 3 to a plus 3, positive 3. And now I can just easily fill these out by adding. So x second, I've got the 1. And that's the only x second I got, so I put 1. Now x, so now I'm looking for x to the first. So I got 4x to the first, 20 doesn't have x, negative 8 doesn't have it. Oh, 3, positive 3. So I just add 4 to 3, that's 7. Because it would be this, it accomplishes the same thing. If I plus 3 here and plus 3 here, it's still 7. If I just switch the sign over there and just add the like terms, it does the same thing. Okay, and then my constants, numbers without x's, I have a positive 20 and negative 8. So I add positive 20 to negative 8. That's 12. Now I can see we have 3 terms. So GCF, and then follow up with your T box. And then you go the same song and dance. You just get the F1, F2, and then that gets your 2 answers. So far I'm not mad. I'm just kind of talking you through it. I'm not just saying do this. We just got to discuss how the equation looks. Determine how many answers x has. Well, I don't see a second power. Do you? So there's only 1. Determine the powers that x has in the entire equation. There are no powers. It's just regular x only. And if I have just regular x only, I'm going to put no boxes needed, okay? That's all you got. Okay, my next one. Determine how many answers x has. Well, 2. Determine the powers x has in the entire equation. Well, find your x's. That one's to the second. That one's to the first, okay? So again, I have x to the second and x to the first, okay? So I'm going to put, when I have these 2 different powers of x, anytime an equation has x to different powers, we need boxes. Okay, before I can make the boxes, I make sure, oh, there's the 0, so we're set, okay? So I see 3 terms on the other side, so that's GCF. And the T. You don't need to put the equals 0. You already have it. Okay? And then I'd get down to where I need to be, and I'd have my F1, F2 from yesterday. Okay, next one. Determine how many answers x has. 2. Because how do I know that? Well, the highest power x ever has is a 2. Okay, and if there's no power at all in x, and those are first powers, meaning there's just 1, and I'm not going to need any factoring boxes. To determine the powers that x has in the entire equation. So, you have x to the second as your highest. Now, is there an x to the first? Yeah, that would be to the first. So again, with these 2, you need boxes. Okay, but I can't make them yet because I don't have my equation equal to 0. Okay, so I write blank x to the second plus blank x plus blank equals 0. Okay, now remember, anything on this side I make into its opposite because it needs to come over here. Okay, putting a negative there does the same thing as the minus 80 does. It's just makes your equation less cluttered. So x to the second, the only thing we have is a negative 16. That's the only number with x to the second. Regular x, well, negative 80. And there's no constant, so I delete that space, and I have two terms, okay? 1, 2. So that would be the greatest common factor box, followed by the difference of perfect squares DOPS box. Okay, and you can stop the process after the boxes have been made. Okay, next one. X to the power of 2 minus 3x minus 18 is 0. Determine how many answers x has. Well, there's that second power, so that's 2. Now, to determine the powers x has in the equation, okay? So we got x to the second. Okay, I know that. Do I have x to the first? Yeah, right there. That one would be x to the first. So again, with those two powers, we need our boxes our factoring procedure. Really, when I say need boxes, that means you need to factor, but you're used to saying the boxes. Okay, so we do need boxes. So is your equation equal to 0? It sure is. What are the boxes I need? Well, that'd be a 1, so that would be 3 terms. So that would be the GCF box, followed by my T box. Okay, draw it how you normally would if you had to solve, but I'm not going to make you go through all that again. Okay, well, I eventually will, but not today. Okay, next one. How many answers does x have? Well, I don't see it to the second power. I don't see it to a power at all. So that means there's one answer. Okay? And if there's just one answer, the reason why I determine the powers x has, I don't even worry about the powers. It's regular x only. Technically, it means x to the first power only, but I'm not going to put first powers if I don't have any other powers. That's dumb. Okay? So if I have just regular x only, no boxes needed. To solve the problem, I would just minus 3x, and then minus 6, and then divide. Okay. Okay, now my last problem I'm going to look at. Determine how many answers x has. So, well, there's x to the second. There's 2. So you see x to the second as your highest power. Now, what are the powers x has in the entire equation? Well, we know x to the second. We already knew that. This x would be to the first, x to the second, and x to the first. So really, it's just a bunch of x to the seconds and x to the first. So with that, we're going to need boxes. Anytime we have x to the second and x first in the equation. But I can't make the boxes till the equation's equal to 0. That's always a rule. Okay, you cannot make, when solving an equation, you can't make your boxes till the equation's equal to 0. Okay, so I make it as 0 myself. X second's the highest. Blank x second plus blank x plus blank equals 0. Okay, now, remember, the things that are over here need to be made opposite. So that's a -1. Now it's positive because it'd be like +1 and then +1 somewhere over here. It does the same thing. Okay, that's a +2. I'm going to switch it to a -2. And that's the same as -2 -2. Okay. All right, now I can put together my like terms. So x to the second, I have a 2. Yep, and a +1. Well, 2 plus 1's 3. Okay, regular x means you're looking for x to the first. We have a -3, and a -2. So -3 plus -2 would be -5. And then for non-x numbers, all you have is that 18 right there, okay? And that's a negative, so negative. Okay, now that I'm set, okay, I'm set. How many terms do I have? I have 3, okay? GCF and T. Okay. So that's pretty much your job here. You need to put the boxes that are needed, but if you don't need boxes, put that they're not needed, okay? Whenever you don't have x to any powers, you know you're not going to need them. Whenever you have x to a power 2, a power 1. And actually, if we had x to the second without the x to the first, we wouldn't use boxes that way either. Now, you haven't been taught what to do there, but yeah.